Hi everybody, in this video I'm going to be walking you through an event detector, which is one of the applications that we can use the D flip-flop, the 74LS74N, which is what you see here. That's one of the ways we can use it, and that's one of the ways we will use it in digital electronics in our class. This is 3.1 in our curriculum. So we went through the D flip-flop in our previous video series. If you haven't watched that, you probably need to go watch that. And basically the idea with the D flip-flop, it's an edge-triggered flip-flop, and what happens is this signal from D will pass through to Q. So if this is a 0, it'll pass the 0 through. If it's a 1, it'll pass a 1 through to Q. But it'll only occur when the external clock is positively edge-triggered. I noticed this because I can see right here we have a triangle, which means it's edge triggered. There is no bubble, which means it's a positive edge. So when the signal coming into this thing goes from a 0 to a 1, that's when the signal will pass through. So notice that I have then an event that's designated or imitated here by this switch, this single pole double throw switch, SPDT on multisim. And what's happened right now is the event is not occurring, which is at a 0, but when I hit the space bar, the event will occur because a 1 happens. We will notice that by the probe lighting up here, and that also means the 0 transferring up to a 1, the positive edge, will hit the clock, which means the signal from D will pass through to Q. So then the question becomes, what makes this an event detector? Why is this special? Okay, why is this different than what we've done before? Well, what makes this different is the fact that D, if you'll notice we trace this back, is tied directly to voltage, okay, 5 volts. And preset and clear are both tied to those as well. That means because these bubbles, if you recall from the previous series, that means we're not really utilizing the preset and clear. We can't just leave those open. We have to tell the circuit what it's supposed to do with those inputs. But because these are active low, because a 0 activates the preset, and we've tied this directly to 5 volts, that means we'll never use it. Okay, so preset and clear not being used. Clock triggered by this single pole double throw switch over here. And D tied to 5 volts, which means it'll always pass through a 1. You'll notice the circuit's already running. Nothing's happening. The alarm's not going off. We have no kind of signal to designate that an event has occurred. But let's say that we go ahead and we flip this switch. Notice what happens then is this is now a 1, and that means that the 1 that was coming into D is now transferred to the alarm. And why that's interesting is if I flip this back off, I can turn the event indicator off, but the alarm is still going off. So imagine like a burglar alarm, for instance. Okay, your burglar alarm is activated, the signal is not going off, but a burglar opens the door. Okay, when the burglar opens the door, the event has been detected, the alarm is now sounding. And even if the burglar alarm is really quick and shuts the door again, the alarm is still going off. Okay, now one problem with this is that we don't have a way to actually turn the alarm back off. Okay, but there's a simple solution for that, so I've designed a second circuit. Okay, I want you to take a look at this. This is almost the exact same thing. We have the clock that's being triggered by this event that's going to occur. Maybe it's a door opening because a burglar's breaking into the house. We have preset and D both tied to 5 volts just like we did previously. We still have Q tied up to an alarm. But in this case, we have clear now going to ground or VCC, and we have a switch here that tells it which one it is. Now remember, this is active low. This is active low. So if I ever take this and I connect this to ground, I will activate then the clear mechanism of this D flip-flop. And if I activate the clear, that's asynchronous. That means the instant that that happens, it overrides the clock, it overrides everything else, and Q will turn off. So now, I gotta go stop my other one. Stop this simulation. Let's come back over here and let's take a look. Okay. Here we go. Event happens, alarm is going off. Burglar closes the door back up, opens it and closes it. Starts to panic because the alarm is still going off. Okay, so how can we turn it off? Well, we can walk over to the keypad and type in a code or do something, and if we happen to type the right code, that in essence, watch this switch, that in essence connects this to ground, which therefore sends a 0 into clear, which therefore activates it, which turns Q off. Now, by the way, this system is now deactivated, so it doesn't matter if the event occurs again. Okay, it's like the alarm system being turned off. We can open and close the door with no repercussions. But if the alarm is reset, okay, now we're back up. Notice I flipped this switch back to 5 volts, so this is not activated. Now the event will be detected again. Alarm's going off, close the door, reset code, turn the code off, okay? So that's an event detector. It detects that something happens, and we can tie in something to the clear mechanism in order to reset that back to 0, back to its original state. Hopefully that makes sense. That is an event detector, which again is 3.1 in our digital electronics class.